Hi again. In this video, I'll be talking about time study and motion study, or time and motion study. First of all, let me give you a brief introduction about the history of the time and motion study. The time study initiated or developed by Frederick Taylor in 1880, about 1880. And he's the first one to use the stopwatch to study and measure the work content with his purpose to define a fair work. So this is one of the concern that we have as a worker, is how we could define a fair work for us. So time study would be one of them, one of the ways to decide if this is a fair work or not. So this is again Taylor in 1880, first one to use the stopwatch. And for the motion study developed by Frank B. Gilbert, and his wife as well, Lillian, developed and redefined the motion study in 1909. And these are just looking into the motion, the movement of the body and the movement of the workers to perform the work, to perform the job. The main advantage of the time and motion study is to simplify the necessary operations, to simplify the necessary operations to make a job easier. Okay, so one is to simplify the necessary operations and to make the job easier by analyzing the process in order to do improvement by eliminating unnecessary operations. All right, so let's take a look into what we have here about the motion study. Motion study is systematic study of the human motions, movement, right hand, left legs, and so on, used to perform an operations. There are different types of motion study. Motion study principles. This is basically guidelines for designing motion efficient work procedure. This is one of them. Number two is analysis of billings. And this is basic elemental motions, which you could divide the job, or you break down the job into smaller elements. Number three, micromotion study, and this is use of motion pictures and slow motion to study motions that otherwise would be too rapid to analyze. And number four, we could do a motion study using charts such as the activity or process charts and simulations chart as well, etc. So there are the four types of charts, or four types of motion studies that we use. What we're going to do, we're going to focus on the one in the second one, which is analysis of their billings. These are the one that we need to talk about it. All right. So in developing work methods that are motion efficient, the analyst attempts to what? Here are the goals. Why we're measuring, why we're analyzing the jobs. We need to eliminate unnecessary motions, combine activities, reduce fatigue, improve arrangement of workplace, improve the design of tools and equipment. Work measurement is concerned with how long it should take to accomplish the job, but not we're not concerned about the job content or how the job to be accomplished. These are, not out of the scope of work measurement. So work measurement, analyzing the job, is related to how long a job should take. Okay, so in order to do this, we have different techniques to do the work measurement. The first one is a stopwatch time study, used to develop a time standard based on observation of one workers taken over a number of cycles. Number two is standard elemental times, deriving from a firm's own historical time study data. So this is based on a historical data. Number three, predetermined time standards. These are based on industry. These are published data on standard elemental times. And number four, work sampling, which is techniques for estimating the proportion of time that a worker or a machine spends on various activities and idle time. All right, so let's see how we could do a stopwatch study. That's the focus for us here in this chapter, is to focus on the stopwatch time study. We need to look into this because this will help you to develop a time standards based on observations of one worker. And these are the steps that you need to go through. First of all, you need to choose a job, a process to study. Number two, tell the worker who's doing the job that you will be studying the process. Number three, break the job into easily recognizable units. Break down the process into steps. And this is, if you remember the flowchart diagram, that would be very helpful here. Number four, calculate the number of cycles must be observed. How many observations I should make? And we have to look into this equation to do the number of observations. Number five, time each element, record the time and rate the worker's performance. Number six, compute normal time using this equation. Number seven, compute the standard time using this techniques or using this function equation. All right. Again, we're going to go step by step and show you how to do a time study. When making a time study, several decisions are made. First of all, number of observations, and we did talk about the equation. We need to apply it. Now, in just a second, we'll take an example. Desired level of accuracy, how accurate you need to be in your time study. Desired level of confidence, or the estimated, how confident you are in your time. All right, now let's take a look into this equation. And this equation will help you to find out the number of observation, the number of observation needed to observe the process. So you can't say, well, I observed it 2 times, 3 times. No, we have to be using this equation to find out how many number of observation that we need. So N is the number of observation, Z is the number of normal standard deviation needed for desire, and there's a table right there. S is the standard deviation of the sample, A is the desired accuracy, X bar is the mean or the average of the sample observation. Also, there's another way for doing it using this equation, N equals Z times S divided by E. And here we use this whenever it's the time is given for us, when it's stated in amount of time, like within a 1 minute of a true mean, for example, instead of percentage. We'll take an example now here to show you how you could calculate the number of observations. So a time study analyst want to estimate the time required to perform a certain job. A preliminary study yield a mean of 6.4. So that's the mean, that's his X bar. And a standard deviation of 2.1. So that would be the standard deviation. The confidence level would be 95%. How many observation he will need if the desired maximum error is plus minus 10. So the error is the accuracy to be plus minus 10%, or if be 1/2 minute. So first one is given to us as a percent. The errors, the sample, the maximum error is given in percentage. However, the second one, B, is given as in minutes. So A, for part A, the standard deviation is 2.1. It's given from here. And then we look into the X bar, which is 6.4. The Z is 196. Where is this number coming from? 196 came from this table right here, 196. So we said confidence to be 95%. So that the Z value is 1.96. This is where we got it. One more time. We have the desired confidence is 95%. We went back to the table, and this is also in the appendix of the book. So 95 is equal to 1.96. And then we have the A to be 10%. All right, so apply the equation, N equals Z times S divided by A times the X bar. So 1.96 times 2.1 divided by 0.1 times 6.4 to the power of 2. That will give you 41.36. So we rounded up to 42 observation. Now for part B, which is given to be half minute of error. So n equal to the z times s, which is already given to us, the z and the s. E is equal to 0.5, so that would give you 67.77 rounded up. So you need 68 observations. So for this process, you need to observe it. You need to observe it for 68 if you need to look into a half-minute error, or if you need an error of 10% plus and minus. This is where you need to observe it for 42 times. All right. So now we're moving into observed time, normal time, and standard time. Let me stop the video right here, and I will create another video separate just for these, separate these and differentiate between these different types of times that we will use it in time studies.